Hello viewers and subscribers of this channel. In this video, I will teach you how to generate movies from series of images or matrices in MATLAB. Here is the movie I created from a series of matrices that represent images of this circle over here in plane. Basically, this is the first image. For example, this is the image number 50, this is the image number 60, this is the image number 100, etc. Once we combine them together, we can obtain the movie that you can see over here. And this movie is saved as AVI file. The technique for generating the movies that I will explain in this video is very useful for visualizing the results of your numerical computations or simulations. Before I start, I would like to mention two things. First of all, those of you who follow my work or who are my subscribers know by now that I always create a post that nicely summarizes everything that I explain in the video. And I'm still following this practice, and here's the post. This post contains all the explanations and codes. Secondly, it took me a significant amount of time to create this video and this post. Consequently, I kindly ask you to press the like and subscribe buttons. Thank you very much. A link to this post is given in the description below. Okay, so let's start. The first step is to define the screen size. In my case, the screen size will be 1000 by 1000 pixels. However, you can also play with these parameters, but be careful over here. If you increase the pixel size, then what will happen? The size of your final movie, that is the size of your file, will dramatically increase. So be careful, because you might have a file that can be 100 gigabytes and it can completely occupy all of your hard disk or SSD space. The next step is to define the radius of the circle. I'm assuming the radius of 50. Then I define a mesh grid. The mesh grid function returns two matrices that define our grid for computation. Now, if you're not familiar with the mesh grid function, I strongly suggest you that you visit my website. Here's the link. And over here, under MATLAB tutorials, you can find a post that nicely explains the mesh grid function. So here's the post. You click over here, and here's the explanation of the mesh grid function. Basically, the idea of mesh grid function is to create two matrices that can be used for evaluating matrix expressions or for defining functions in two dimensions. The next step is to define the trajectory of the center point of the circle. Basically, my circle will move along the main anti-diagonal of my screen. That is, it will move along this direction. The next step is to generate a series of images that will be glued together in order to create a movie. And this for loop, starting at the code line 11 and ending at the code line 15, is used to create a series of images. But before we explain this for loop, let us briefly explain the principle for generating the images of a circle. Let us assume that we want to draw a circle with a certain radius r and with the center at xc, yc, where this is the x coordinate and this is the y coordinate of our screen. Now, obviously, the region inside of the circle should be painted with a certain color. And the region outside of the circle should be painted with a different color. For example, the region outside should be painted by using the green color, and the region inside of the circle should be painted by using the black color. Now, remember that every point over here is a pixel with certain coordinates, right? And this pixel corresponds to an entry of a matrix. So what do we need to do? We basically need to define some condition that will distinguish this area, that is the area outside of the circle, from the area that is inside of the circle. To make this condition, we need to recall the equation of the circle. And the equation of the circle looks like this: x minus xc squared plus y minus yc squared is equal to r squared, where again xc and yc are coordinates of the center and r is the radius. Now, points on the circle directly satisfy this equation. That is, if we substitute the values for x and y over here, and if these values correspond to the points on the circle, this equation will be identically satisfied. Now, if we choose a point over here, then this point will satisfy this inequality. On the other hand, the points over here will satisfy this inequality. So the condition should read somehow like this: if x minus xc squared plus y minus yc squared is smaller or equal or less than equal than r squared, then we assign to these points 1. This means that the point belongs inside of the circle. On the other hand, if this condition is not satisfied, then we assign to the set of points, that is to coordinates, 0. So this is a basic principle that can be used in order to distinguish points that are inside or outside. We simply test if x minus xc squared plus y minus yc squared is less than equal than r squared. If that's true, then we know that a point is inside of the circle and this point will be painted with a black color. Otherwise, the point is outside of the circle and this point will be colored with the green color, for example. Let us go back to our for loop. Basically, the code line 12 is used to code the condition for distinguishing the regions inside and outside of the circle. To understand this code line that is very compressed, let us modify our problem by only considering 10 by 10 grid. Let us change the radius. Let the radius be equal, let's say, to 3 or even 2. And let us change this trajectory to go from, let's say, 2 with a step 1 until, for example, 9. Let us do the same thing over here. And let us run this code. Okay, and let us see the result. Let us choose this value of image circle matrix and let's see what will happen, the middle one. Okay, so here is the result. Now, what happens over here? We can clearly observe 10, 10, 10, 10, 10, 10, and the region inside of the circle is represented to 150. So here's our circle, and we can basically even plot it if you want, right? And we can do that by typing image_sc, or let us go back and do something like this. And here's the result. Of course, this is a very pixelized representation of the circle. However, if you increase the dimensions of the matrix, you will basically see a more regular circle. So 150 corresponds to the region inside of the circle, and basically 10 corresponds to the region outside of the circle. Now, let us go back and let us analyze the code line 12. And let's see what's happening over here, while at the same time we can watch this matrix over here. So what happens over here? Here's the condition. The condition is over here. Now, if the matrix elements are over here, this means that this condition is not satisfied. This code line will return for the corresponding pixel value 0. Now, if you choose a point over here, that is, if you chose the matrix entry corresponding to this region over here, this condition will be satisfied, and this entry, actually the entry of this matrix corresponding to the pixel, will be equal to 1. So this matrix over here is a binary matrix that represents the regions inside and outside of the circle. If the region is inside of the circle, the corresponding matrix entries will be equal to 1, and if the region is outside of the circle, the corresponding matrix entries will be equal to 0. After we have defined this binary matrix, we scale this matrix by a proper value. I'm doing this scaling since the colors that I'll be using range from 1 to 256. So I'm choosing, for example, a value over here that corresponds to, let's say, a certain color, for example, a pink color. Now, we don't like the regions outside of the circle to be represented by 0, since 0 will probably be a black color. Then we choose a value over here that's equal to 10, and that will correspond, for example, to some color that has high contrast to the color represented by 140 over here. And this is how we generate a series of images. Okay, now we can basically watch a movie, right? We can watch a movie, but before we watch a movie, let us now reverse our changes and let us play a movie of the matrix that we have previously defined, and here is how our movie looks like. So what I'm doing over here, I'm iterating over this series of matrices represented by image circle with a pause of 0.2 seconds, and you can obtain something like this. So let us try to speed up this by, for example, choosing 0.05. So let us execute this and let's see what will happen. Okay, so this is our video, or better to say, this is just a visualization of our results. The video will be created at the end of this video. Basically, I will explain you how to generate a real AVI file. Next, we explain how to generate the AVI file of our movie. That is, we explain how to generate a real file that you can play later on with some movie player. First, we define the color map. We choose the cool color map, and there are some other options that I listed over here that represent different color maps. Then we open the video writer. We use this code line video writer, we specify the file name, and we specify this parameter indexed AVI. Then we choose the frame rate. We can choose 25 or 50 or an arbitrary frame rate. Then we set the color map over here, and let's look into the properties of this object. We can basically evaluate and see the details of the movie object. We can see the path, file format, color channels, frame count, frame rates, and other properties that you can set as you wish. Here we open the movie object, and in this code line, actually in this for loop, we basically write our images step by step. That is, we iterate over our array of images and we store image one at a time. And this video writer will make sure that we are basically writing the images with the frame rate of 25 frames per second. So let us execute this code line and let us close the movie object, and finally we can also play our file in MATLAB. So here is our basically file. This is our circle. It moves along the anti-diagonal of our screen. Okay, so if you don't like this MATLAB movie player, you can of course access your code, or actually your movie, in the folder, and the path of the folder should correspond to this path over here, to your current path in the MATLAB workspace, and you can simply open your video, and here's the video. Okay, that would be all for today. I hope that you like this video. If you like the videos I create, please subscribe and like my channel. Thank you very much and have a nice day.